Hello everyone, we are here to present our project RNN and LSTM for sequential sentiment prediction using IMDb dataset. This project is based on sequential data modeling where we compare different deep learning models such as a simple dense neural network, a CNN model and LSTM model to check whether which one perform best in a sentiment classifications. The task given us to build a LSTM model for sentiment analysis and compare its performance with the CNN and dense model and show its accuracy and improvements and generate the graph and ROC AUC curves and to provide a trained model in .h5 format. The sentiment analysis is a sequence problem because the meaning of sentence is depend on the order of the word. The LSTMs are designed to understand long-term dependencies, making them ideal for tasks. The data we used IMDb dataset, which consists of 50,000 movie reviews, and it is equally divided into the positive and negative sentences. It is pre-processed into the sequence of integers. Only top 10,000 most frequent words are included. We pad every review to fixed length of 200 words to ensure uniform input size. Thank you.
I am going to explain about the preprocessing. So first we loaded the IMDb dataset. So we can see here we have processed the IMDb dataset. So we loaded the 10,000 words in vocabulary. So we pad all the sequences to maximum length equal to 200. This ensures every input has same size. When it comes to building and training LSTM model, our LSTM model consists of embedding layer, converts integer tokens into dense vectors of length 128, LSTM layer with 128 units, learns long-term dependencies in sequences, dropout is 0.3, it prevents overfitting, dense layer, sigmoid, outputs a probability between 0 and 1, training. We train the model for 5 epochs with the early stopping to prevent overfitting. Thank you.
I am going to explain about CNN model, dense model, the graphs and ROC AUC graphs. So the CNN model actually extracts local patterns such as small phrases like very good, worst, movie, etc. Its architecture is as follows. Embedding layer, conv 1D layer with 128 filters, global max pooling, dense layer, output layer, sigmoid. So CNN learns n-gram features and it is usually faster than LSTM. Dense model. So this is the simplest model with embedding, flatten and dense layers. But flattening loses the sequence structure, so accuracy is usually lower. Then we have plotted two graphs for each model. One is accuracy versus epochs, other one is loss versus epochs. These graphs help us observe how fast the model learns, whether it is overfitting, whether validation accuracy matches training accuracy. LSTM generally shows smoother learning because of sequence understanding. Then we also have ROC AUC curve for all three models. The curve shows false positive rate x-axis, true positive rate on y-axis. Higher AUC means better classifier. That's it. Thank you.
Comparison plus conclusion. Final test accuracy. We evaluated all the three models. Uh, we, uh, we evaluated all the three models. Python, LSTM model, evaluate X text, Y text. CNN model, evaluate X text, Y text. Dense model, evaluate X text, Y text. Typical accuracy results. The model is the test accuracy, and the nodes. Dense model, which consists of 82% of test accuracy, but it is weak at sequential data. The CNN model, which consists of 85 to 87% of accuracy, which is good at trace level features. The LSTM model, which consists of 80 to 90% of test accuracy, best at understanding long range contest. Next, conclusion. The LSTM model performs the best among all the three. LSTM captures the long term dependencies and the advantage of CNN and dense. CNN is faster but less accurate. Dense model performs the worst because it ignores the sequential order.